just, of course, y, yes, thank you. Okay, yes, y here. So then we will integrate from, yeah, h1 of y to h2 of y, the function f with respect to x, and then we will integrate the result with respect to y from C to D, like this. That's the general idea that we had a look at last time. I think we also mentioned another result. I can put this as number 4, is that if you integrate a function f over a region R like this, then this usually represents what? Not the area. I can say. Yeah, this is if you have a region R in the xy plane, and in this region you have a function f, so z equal f of xy, so it's going to be its graph maybe something like this, then the integral, actually this integral actually represents a volume, yeah, this volume here. So a double integral of a function f represents a volume. We will see this in a moment. In fact, it's part of the second section. Okay, so that is some general ideas that we discussed last time. Now I want to move to this section, 13.2, which is basically, we'll talk about areas here, we'll talk about volume, and we will talk about the center of mass. Okay, so first, the area. When you want to find the area of a region R using double integration, then you will find it by integrating the function 1. So the area, you will find it by using this formula. So double integral over R of the function 1, so multiplied by dA, so I will just write dA, and we will see some examples in a moment. So that is the first formula that we need to do. The second formula is the one I just mentioned about volume. If you want the volume of a certain solid, yeah, where the function, yeah, the volume will be the double integral over R of the function f, dA. So that is the second rule regarding the volume. So you want the volume, you have a function f here, defined over a region R. The volume of the solid is just the integral of the function f over the region R that you have here on the xy plane. So this will give you the volume of the solid here. Okay, so these are the two formulas that we will be using here. So let me, yeah, so here is the first example. Find the area of the region bounded by the graph x equal y squared, which is this blue parabola. X equal y squared. Y minus x equal to 3. What is y minus x equal 3? What is the graph? It's a straight line, yeah? It's given here. This is the line, which basically, this one, we change it into, yeah, y equal, okay. In fact, yes, okay. And then we have y equal minus 3, which is this black line here, horizontal line, and then y equal 2 is the top line here. So basically we want this region, the area of this region. What is its area? So you can see this region here. If you go from left, so first I will say the area is the double integral over R of dA. That's it. That's the rule. Yeah? Now, I want to integrate over this region R. Look at it. Look at the region R. Is it from a function down to a function up, or is it from left to right? From left to right, yeah? X equals something on the left to X equals something on the right. And Y goes from minus 3 to 2. That's it. So basically then, this area, I will find it first by integrating with respect to X. What is the curve on the left, the line? Y, but I need to write it as X equals something, yes? So change this. X equal Y minus 3, huh? So from Y minus 3 to, what is the top? What is the curve? What is this curve here? X equal? No. X equal Y squared. That's it. Remember, I need X equal on the left and X equal on the right. Like this. So it will be Y squared. And then, what do I do after that? dy from Y equal minus 3 to 2, like this. Okay, great. So let me keep minus 3 to 2, like this. Now, what is the integral of dx? Or, this is like 1, yeah? It's like 1. What is the integral of 1? X, yes, that's it, x. Hmm? Yeah, this one, it's a bit like you have 1. Imagine it's like a 1 there. Yes? What is the integral of 1? X. Basically, the integral of dx is the integral of dx is equal to x, basically. Okay. Right. Now we put x equal y minus 3 to x equal y squared dy. So let's substitute. So what do I get if I substitute? Can I have some answers? Yeah, so it will be y squared. Yeah, you substitute this here, and you substitute this also here. Yeah, So it will be y squared minus y minus 3. Okay, like this, yeah? dy. Okay, now it's very easy to complete this. What is the integral of y squared? Y cubed over 3 minus, what is the integral of y? Y squared over 2, and then plus a 3. What is the integral of the 3? 3y, yeah, 3y from minus 3 to 2. And you then take your calculator, and you should be able to find this result without too many problems. You substitute with the 2, yeah, and then you substitute with minus 3. So can you try it? What do you get? Okay. Someone did not write their name here. Okay, now, do you know how to do this? There is in the calculator, you can actually write the x cubed over 3 minus x, and then evaluate it at 2 minus the value at minus 3. It's a fairly simple, and I think you will get 175 over 6. Did anyone get that? 175 over 6 is square units, whatever the units are. This is obviously 30 something, yeah? Not 30, 20, yeah, 29 point something. Or, yeah, okay. All right, no problem. You can do that without too many problems. So that is an example of using double integrals to find the area of a region R. Now, using double integral to find the volume. Okay. So I want to find the volume of the tetrahedron bounded by the plane 2x plus y plus z equal 2 and the 3 coordinate planes. So first, I need to graph this a little bit. Yeah. So to understand, to find basically what is the region R, what is, yeah, so here, so this is a plane, yeah? Now, to graph this plane, to graph it, I can think of it, I can look at its intersection with the axis. For example, at what point will it cut the x-axis? What happens on the x-axis? What are the values of y and z on the x-axis? If you take a point on the x-axis, 0, yeah? 0. So put 0, 0. So you will get 2x equal to, so x is equal to 1. So the plane will cut the x-axis at the point 1. At what point will it cut the y-axis? At 2, yeah. You can put x equals 0 and z equals 0. You can see that it's going to be 2. And finally, it will cut the z-axis also at 2. So what you have is a plane which is like this, and it cuts. So it comes down like this, and it cuts these three axes at these points like that. So, and then you have the three coordinate. What does it mean, the three coordinate planes? What are they? Yeah, the coordinate planes means the xy plane, the yz plane, and the xz plane. So you have three planes, one here, and the bottom one is like this. So basically, what we are getting is this plane and then the three sides, yeah, the three sides like that. So what we want is the volume of this region. It's called the tetrahedron. Each side, how many sides does it have? Can you look at it? Can you see how many sides? Not three. You don't, okay. If you understand what's happening here, you can see how many. So there is this green side, there is, the XY plane, the XZ plane, and the YZ plane. So how many sides is that? Four, yes. There are four sides. Four sides. It's a bit like, imagine you have a plane which comes down like this, from here, from this corner, yeah, like this. So this will be a side, this will be a side, the bottom will be a side, and then the plane itself will be another side. So you have basically three sides. Now, to find the volume of this, imagine a line going like this. What is the function here? What is the function? What is z, the value of z here? On the green plane, remember the green plane, its equation is 2x plus y plus z equal 2. So I can get z from here. What will be the z? 2 minus 2x minus y. That will be the function f. This is, if you want, our function f of xy that we are going to integrate. Yeah, so here, f of xy. Now, what do we need? So we have the f. What do we need now? Remember, volume in general is the double integral over r of the function. That's how you get the volume. F being this z equal at the top. Yeah. So what is missing here? The R, yes, we need to find the R region. The R, you can see from here, we need to find the region R on, yeah, okay. So let me just, okay. Yes, so we need the R. R is this triangle here. on the XY plane. R is here. So we need the R. X, Y. The region R goes from X equal 1 to Y equal 2. Yeah. So this will be the region R like this. So I want to integrate in this region R, which is given by this. So what I want is the equation of this line. Now, how did we get this line here? It's the intersection of this plane with this line here, which is this one, is the intersection between the plane and the XY plane. So that means Z is equal to 0. So to find the equation of this line, put Z equal 0. So you will get 2x plus y equal to 2. Yeah. So that means I can write this as y equal, if I want to have it in terms of y. So it will be 2 minus 2x like this. So that is, okay. Now to integrate in the region R, I will integrate from y equal 0 to y equal this. And then with respect to x from 0 to 2, that's it. So now I can write the volume double integral over R of the function z, which is here, 2 minus 2y, 2 minus 2y, 2 minus 2x minus y. Okay, so 2 minus 2x, yeah, so minus 2x minus y dA. So I will integrate this from y equals 0 to y equal 2 minus 2x. So I put 2 minus 2x minus y. So this is integrating with respect to y. And then dx from 0 to 2, like this. So now I need to calculate this. Okay, so what is the integral of 2y, huh? So 0 to 2. So I get 2y there. What is the integral of minus 2x? Yeah, minus 2xy, yeah, just because it's a constant. And then the integral of y will be minus y squared over 2 from y equals 0 to y equal 2 minus x. All of this integrated with respect to x from 0 to 2, like we said. Also, sorry, what was x was from where? No, 1. Yeah. Yeah, 1, yes, yes. This is 1, yeah. Thank you, yes. Thank you. Okay, great. Yeah, x from 0 to 1, of course. Thank you. Yeah, so here 1, and okay, great. Now we kind of substitute. So let's see how we complete this. So we will 0 to 1. So let's substitute. So it's going to be 2 times 2 minus x. 2 minus 2x, yes. Sorry. Yeah. Okay. And then minus 2x times, again 2 minus 2x, and then minus 2 minus 2x that we square, and we put this over 2, and we have dx. Yeah, dx, like this. Okay, now shall we complete this, or do you know how to complete this? Yeah, very simple. You kind of open this up. Yeah. So let me just actually try and do this. So what will it be? 4 minus 4x, and then another minus 4x plus 4x squared. Now you need to open this square first here, yeah, which will give you 4 minus 8x plus 4x squared. And we are dividing everything by 2, so it becomes 2 minus 4x plus 2x squared, and then you integrate this with respect to x. I will leave you the rest. I will just give you the final answer. You can simplify, or you can just integrate every term. It's up to you. I think the final answer will be 2 over 3 cubic units, whatever these units are. So that's the general idea here. Is that okay, or? How did you get 4 planes? How did I get what? 4. The graph, this graph? Yes. The 4 sides? Yes, the 4 sides. Oh, the 4 sides. Okay, let me just, let me open this. Basically what you have is, if you look at that shape, you have the x, z, the x, o, z is one side. Yeah. Then the z, y axis is another side. It's like this is one side, this is another side, the floor is another side, and then this plane, which comes down like this, is another side. So how many sides is that? 4. Do you understand? So you have one side, 2 sides, 3, and then the plane itself, which comes all the way from Z here and sliding, kind of, covering the whole thing, is the 4th side. It's like a 3D pyramid. Sorry? Yeah, it's like a pyramid, exactly. It's a pyramid, but its base is a triangle. Usually a pyramid, you could have a pyramid which is a bit like this, where the side, the bottom side is a rectangle or a square, but here, the bottom side is like only goes from here to there. So it's like a triangle, a triangular thing. Do you see that? So then what you do is, when you have this kind of shapes, this one on the plane XY is the region R, basically. And the function f you want to integrate will be the cover. What is covering this? So this will be z equal f of x, y. Then the volume of this will be the integral over the region R of the cover function f of xy dA. Do you understand this? Yeah. So here, basically, the cover comes from the plane. So you need to find the z from here. And then the r will come from all these shapes. Basically, r is a triangle. And of course, if you want to integrate over the triangle, you need the equations of the different sides. Here, this is y equals 0. This is x equals 0. For this line, I hope you understand how did we get this? Because it's the intersection between this plane with xy plane. So that means I need just to put 0 here. You put 0 there, and you will get the equation of this line from this to this point, like this. So that's basically what is happening here. Okay, anyway, we will get the chance to practice a bit more. Yeah. Here is another example of a volume. I warn you, these are not simple in general. Finding volumes of solids in space, not very simple, because the graphing itself sometimes can be a problem. So generally speaking, we will not give you very difficult things to find volumes of. Here we have another question on volumes. This time the solid is bounded by z equal 4 minus x squared, which is basically the green thing here. Z equal 4 minus x squared is like a parabola coming down. So it's this one, and then x plus y equal 2 is this purple plane. So which goes from this point 2 to this point 2, like this. And the three coordinates planes again, x equals 0, y equals 0, z equals 0. So in the end, what we will get is a solid which is here, and it's when you put its projection into the xy plane, you will get a triangle again as the region R. Now, what is the cover this time? This cover that we mentioned. What equation will give us the cover? It's the green thing, yes? Yeah, it's the green one which is covering. So the green is given by z equal 4 minus, yes. So our function this time is really 4 minus x squared. And the region R, look at it. What shape is it? It's a triangle. And it goes from x equal to y equal to like this. So here is the region R on which we need to integrate the function f to find the volume. So, so the volume will be the double integral over R of the function for minus x squared dA. Now to do that, what do we need after this? What do you think? The region R, yeah? We need some equations there for, of course, this is y equals 0. That's not a problem. This point, this line, I need its equation. Yeah, this equation is, yeah, it will come from here, from the plane itself. So it's basically x plus y equal 2. So we can write it as y equal 2 minus x. So I could integrate with respect to y from 0 to 2 minus x, and then with respect to x from 0 to 2. That's it. That's how we're going to find the volume. So it's going to be the integral with respect to y first. By the way, I could do it with respect to x also. Huh? It's possible. You just go from left to right in that case. So from y equals 0 to y equal 2 minus x, and then with respect to x from 0 to 2, like this. So after that, it's really simple. So from 0 to 2, then the integral of 4 is 4y, yeah? 4y, and then x squared y, yeah, from y equal to 0 to y equal 2 minus x, and then I will integrate that with respect to x. Okay. So substitute first. Huh? So we need to substitute. It's going to be 4 times 2 minus x squared times 2 minus x. Minus at 0, it's going to give us 0. Yeah, 0 here, so nothing there. So dx. After that, it's very simple. So you will get 8. So that will give you 8x when you integrate it. Yeah. And then you will get what? Minus 4x. What's the integral of minus 4x? Minus 2x squared. Thank you. Yeah. And then you will have this multiplication. So what will it be when you integrate it? Minus 2 over 3 x cubed. Good. And finally, this one, x cubed. Huh? X cubed. So it's going to be x power 4 over 4 from 0, yeah, from 0 to 2. That's it. And you just calculate this. At 0, it's 0, obviously. So you just calculate it at 2, and the final answer, I think, is 6.666, etc., or 20 over 3. Of course, make sure that because we are calculating a volume here, your answer should always be a positive number. It's always going to be a positive number. Yes? Because a volume is, of course, a positive thing. So if you find negative here, that means there's something wrong in your calculation. Same thing when you are finding the area. If your answer is negative, then clearly there's something not right in your calculation. So please bear that in mind. It's important. Okay, so that is basically the examples here on volumes. Now, the other thing here is moments and center of mass. Here you have a lamina, which is like a flat thing, which is made of metal, say, and you want to find its center of mass. Some of you, obviously, you do physics, yes? So you must have center of gravity or center of mass. So these are important things in physics. You assume that this lamina has a density of given by rho of xy. That's the density of this lamina. And then once we have that, then we can find the mass by integrating the density. So what you see here is the mass in grams or whatever. So to find the mass, you take the double integral of the density function. Okay, that is the mass. And then we want to find my, which is the moment with respect to the y-axis. It's given by this. Mx, the moment with respect to the x-axis, it's given by this integral. So these are all important formulas. So 1, 2 here, 3, and finally the center of mass given by my, that you divided by the mass m, and that's the x coordinate of the center of mass. Center of mass is a point. X coordinate, y coordinate. The x coordinate is this, and the y coordinate is this. So these are all just formulas, rules that you need to use when you want to find the center of mass of like a flat surface like that. So here is an example. Okay, finding the center of mass of a lamina like that. Find the center of mass where the lamina is in the shape of the region bounded by y equal x squared, y equal 4. And the density is given by this function. So this is really quite a simple calculation to do. There's no, what is the first thing we need to do here? You need to draw. Yeah, we need to know what is this region, how does it look like, so we can decide whether we need to integrate with respect to x first or y, what is a, what is b, and so on. So we need to draw. Fortunately, this drawing is easy. Y equal x squared is parabola, obviously. You know, that's not an issue. So y equal x squared is here. And then you have y equal 4, which is a horizontal line at y equal 4, like this. So this is really the shape of the lamina. And we want to find where is the center of mass of this lamina. Okay, so I want to find x bar, y bar. Where is the center of mass? Okay, so to do that, well, we have to calculate various things, yes? What is the first thing we need to calculate? The center of mass. You can see we need small m, we need my, we need mx. Once we have this, then we can find the center of mass x bar and also y bar. So we need 3 calculations. We need to do these 3 calculations. So first, I want the mass m. It will be the integral over r of the density. What is the density here? 1 plus 2y plus 6x squared dA. So that's what we need to calculate. Yeah. All right. Now, we want to integrate over R. Do you think we do it with respect to X first or Y? Y, yes, we need to do it with respect to Y from here to here. And then with respect to X from minus 2 to 2, yes? You can see that the intersection will be x squared equal to 4, so x is plus or minus 2. Okay, so that means the mass m will be the integral with respect to y from x squared to 4. 1 plus 2y plus 6x squared dy. And then, after that, dx from minus 2 to 2. I think we can do that. There is no major problem here. We can say minus 2 to 2. So what is the integral of 1? Y, yeah, good. 2y, y squared, 6x squared, 6x squared y from y equal x squared to y equal 4 dx. Okay, so now it's long calculations, by the way, but they're fairly simple. So we substitute, so you will get 4 plus 16 plus 24 x squared minus x squared plus x to the power of 4 and then plus 6x also 4, huh? Like this. And all of this dx. Okay, I will leave you the rest. It's a really simple calculation. You open this bracket, you integrate with respect to x, you substitute, and you will see that the answer will be 130. Okay, so you can complete this, no problem. Now, what is so that's the mass of this lamina, yeah? Its mass, in grams or whatever the units are. They're not telling us. Now, what is the next step? My, yes, my, okay. So my will be the double integral over r of x multiplied by the density. So let me just write, I will not do the calculations, I'll just give you, over r. Then x multiplied by the density will be okay. So we multiply x by the density, rho. So it will be x plus 2xy plus 6x cubed, yeah? X plus 6xy plus 6x cubed. And then we integrate this. Sorry, yes, plus 2xy, yes. Yeah. Okay, yes. And then you do the same as we did before. I think if you do this calculation properly, the answer will be 0. So I'll just give you the answer there. And then we need to find, finally, m. What is the third one? Mx, which is the integral over r of y multiplied by the density. So integral over r, y multiplied by the density will give you y plus 2y squared plus 6x squared y dA, like this. Okay, again, I will leave you this calculation. I'm pretty sure you can do it. So, and this time we get 318. So now, can we find the center of mass? Yes, we can, yeah? After that, it's really simple. So the center of mass is, remember it's two coordinates, yeah? You need x bar, which is my over m. So it's going to be 0. And the y coordinate is mx over m. So it's going to be 318 over 113, which is 2.8. So the center of mass is 0. 2.8 is where the mass of this is basically, you can think of it as the center of this. So it's somewhere here. The center of mass is on the y-axis, 0, 2.8. Are we okay with this? Which, it's always the region R. R is finished. Once you draw, we're always integrating over the same region. Do you understand? Yeah, R is the shape of this lamina. That's it. So, but good question, yes. No, I mean, the integral is always, all these integrals are over the same region R, which is the shape of the lamina which is given to you. Yeah, this is like, think of this as a metal piece, yeah, which is cut in this shape, and you want to know where is the center of this metal piece. Yeah, that's the thing. So R is still the same. So the boundaries, so these boundaries are exactly the ones you will use here, yeah, and also the one you will use here. So y will always be from x squared to 4, yeah, x squared to 4, and x will always be from -2 to 2, yeah, x from -2 to 2, like this. Okay. Yeah, after that we also have some physics quantities which are called the moments of inertia, which are given by these formulas. And this is a measure of how easy you can rotate an object about the y-axis. So about the y-axis, you use x squared multiplied by the density. And about the x-axis, you use y squared multiplied by the density, like this. So if we consider the same example as before, let me calculate these two moments. So I want Iy. So it's going to be the integral over r of x squared multiplied by the density. What was the density? 1 plus 2y plus 6x squared dA, like this. Yeah, and then of course we said this integral is just the integral with respect to y from x squared to 4. So this will be an x squared plus 2x squared y plus 6x to the power of 4. So this with respect to y, and then the answer with respect to x from minus 2 to 2, like this. So let's do it. Let's do this one, and then I will leave you ix the same thing. All right, here. So what's going to happen? It's going to be x squared. So the integral from minus 2 to 2. The integral of x squared will be x squared y, yeah, plus x squared y squared. Good, thank you. Plus times y. Okay, great. From x squared to 4. Okay, great. So, are you okay with this? Yeah? All right. Now we substitute. We put 4. Remember, y is 4, huh? It's y, not the x. So always be careful about this, please. So it will be 4x squared plus 16x squared, yeah, plus 24x to the power of 4, all of this, and then minus x4, yeah, plus x6, huh? To the power of 6, and then plus 6 also, yeah, like this. And then all of this dx. All right, good. Okay, so how many x squares are we having here? 20, huh? 20. So if we integrate the 20x squared, we will get. Can we do that? Yeah. So this and this will give us this. How many x4s? 23, huh? 23. So it's going to be plus 23 x5 over 5. Yeah. And so that's okay. And then the x6 minus 7, yes? With a minus, there is a minus there. So it's going to be minus x to the power 7. Yeah, that's it. X to the power of 7. Yeah, x power of 7 from minus 2 to 2. By the way, because these powers, notice that these powers are all odd, yes? x3, x5, and x7. So find the value at 2 and then multiply it by 2. Because this is 2 and minus 2. So just substitute with 2, and then whatever your answer is, multiply it by 2 and see what happens. Anyone? Can you do the calculation? Is it 0? No. It should not be 0, I think. Or it could be 0, yeah, it could be, I guess. Is it 0? Yeah. I actually have a complete.
2176 over 15.
145. Yes. 145? Yeah, this is exactly what I have here, yes. So I have 145, and I will give you the answer for IX. You can calculate it yourself. IX, when you do it, you will get 983, 983, like this. You can check it yourself. IX will be same, but here instead of x squared, you use y squared. That's it. And then you just multiply. The boundaries are exactly the same. Yeah. These don't change. So you calculate this. Okay, that's basically what there is in this section. Just time maybe to do. Can you try this one, please? Can you try this question? I'll give you some time to have a look at it. So you want to find the area of this region between these two curves. Sorry? 13.2 not in the test, but 13.1 yes. Yeah? This one no. By the way, next class, because we're done with this, next class, I will do the practice test with you here. So please come, we will review for the test. Make sure you're okay. If you have any question, bring them with you. So on Thursday, we will review for the test. Okay, so let's have a look at this region and find its area. What do you need to do first here? Graph, yes? As always, you need to graph. So you need to draw the graph and then remember finding the area means just integrating the function 1. Yes?
I'm still getting 0.
You're still getting 0 there?
Yeah.
It cannot be 0 because at 2, yeah, can I have I think you, no, because you're integrating. This is already integrated.
No,
This, eh?
I can't have it.
So let me just check. Why are you integrating here? This is already integrated. Yeah, this one is already integrated. It's already the integral. So don't put it.
Which one?
Where are we? Yeah, here you are writing this, yes? From 1 to 2. Why are you using the integral?
Substituting that's
Huh?
substitute.
Yes, it's not an integral anymore. Do you understand? Yeah, there's no integral here. Just remove the integral, put this. Can you remove the integration? So, yeah, exactly. And then calculate at 2. 2, yes. Multiply that by 2. Yeah, that's it. Sorry? All right, sorry, I did not have the question. Yes, sorry. Yes. So between y equal x squared and y equal 8 minus x squared. So one is a parabola going up, the other one is coming down. So we need to, try this. Try this. Try. On paper or writing up or anything else. So the first thing you need to do is to graph, is to draw the region. Something? No. You don't know how to solve it? Okay. Yes, you need to, huh? Sorry? This is not in test 2, but very similar things will be in test 1, so you need to know this. Yeah, because the region areas will are also in the 13.1. 13.1 is in the test. So here you have the region bounded by y equal x squared. Some of you still don't know how to graph this. No, this is not acceptable. Really, girls, come on. Y equal x squared is a parabola. Very simple. Y equal 8 minus x squared is another parabola going like this. And this point is 8. Come on, I mean, you are doing engineering, girls. You need to know this thing. Calculus 2, you don't know how to graph y equal x squared or 8 minus x squared? Not acceptable, really. So here, y equal 8 minus x squared. This is y equal x squared. The area is the double integral over the region R of dA. Yeah, this is what we just said a moment ago. Now, you want to integrate over R, so how are you going to do this? First, with respect to Y. Yes, from here to here. And then with respect to X from, we need to find these values, yes? You need to find these values. So you solve x squared equal to 8 minus x squared. So 2x squared equal to 8. X squared is 4. So x is plus or minus 2. So we say then, therefore, the area will be the integral from minus 2 to 2, integral from x squared to 8 minus x squared of dy dx, like this. Now, that means from minus 2 to 2, what is the integral of dy? Y, yes? Y. That's it. Y from x squared to 8 minus x squared dx. Okay. After that, you can chill a bit and calculate this. So it will be integral from minus 2 to 2 of 8 minus x squared minus another x squared, huh? Yeah. So you substitute and you substitute like this. All of this dx. Okay. After that, the integral of 8, 8x, yeah, minus 2x squared, which we integrate 2 over 3 x to the power of 3 from minus 2 to 2. And then you find the answer. Which one? 2 and minus 2? Okay. They are here, yes? From the intersection of the two curves. The intersection of the two curves will give you the boundaries for x from here to here. So from, yeah, this minus 2 to 2. And with respect to y, we're integrating from this parabola to this parabola. So from x squared, the bottom one, to 8 minus x squared, the top one. Try 5, and then, yeah, try number 5, see what happens. Yes?
When do I put that's dy and dx?
Sorry?
That's an equation.
When do you do what?
When I only plug in the boundaries with dy. Without an equation in front of me.
There's no equation here.
Yeah, when do I do this?
Yeah, if you want the area, remember the rule for area is the area of, yeah. Yeah, the area is just the area of a region R is the double integral over R of dA, nothing, which means just the function, it's like 1 here. This is the rule, yeah? So no, there is no function here. If you have a function, it becomes what? If you have, huh? It becomes a volume, exactly, where the top is this function. Yeah, like that, exactly. Okay, so what's the final answer here, guys? Can we check? Anyone has an answer? How much? Yeah, question 1, yes. this is as a fraction? 54 over 3? 64 over 3. Okay. Anyone has that? Yeah. It's basically the value of this at 2, yeah, at 2, which is 16 over 3, which is 32 over 3, multiplied by 2. Yes, 64 over 3 is the correct answer, yes. 64 over 3 square units is okay. So try 5. This time you have y equal x squared and x equal y squared. Yes, so you have okay, so this time it's this region, yes? Between the two parabolas. So this is x equal y squared. The green one, and then this one is y equal x squared. So the area is the double integral of dA over the region R. Now this time, what did you decide, guys? Would you integrate with respect to x first or y? Why? You could do it both ways, by the way. Huh? It's exactly the same. If you do it with respect to y, then it's fine. It's going to be, first, by the way, you need the intersection. So you need to solve, yeah. Where is basically x squared? This one will be 1, yes? Yeah, 0.1. Y is equal to x squared and y also. The other one, this one you can change it into y equal square root of x. Yes, you can change it into y equals square root of x. And you solve this equation, you will see that you get two solutions, 0 and 1. Yes. So you will get the boundaries 0 and 1. So then we can say it's the integral with respect to y first from x squared, good, to square root of x, huh? Like this. And then you integrate that with respect to x from 0 to 1, like this. That will give you the area that you want. After that, we integrate. So the dy will give you y, yeah, just y, from y equal x squared to square root of x dx. So it's going to be the integral from 0 to 1 of square root of x minus x squared dx. Okay, great. And then we integrate each one of these. If you want to integrate x, square root of x, you can think of it as x to the power of half. Yeah, it's better to think of it as x to the power of half. So when you integrate it, you add 1. So it's going to be 3 over 2. So it's going to be 2 over 3 x 3 over 2 minus the integral of x squared, which is x power 3 over 3 from 0 to 1. Just substitute. It's 1 over 3, so yes. Because when you substitute with 1, you get 2 over 3 minus 1 over 3. And at 0, it's 0. So it's just the whole thing is 1 over 3. Does that make sense? It's okay? So that is how you get the area of this shape. Any questions here? It's okay? Let me just... Can we take another 5 minutes, perhaps, to do this one? And then we can here, this is similar to that question about a plane coming down. And then you have the 3 coordinate plane. It's going to be done exactly the same, except that the region this time, this plane will come from 6. It will cut the x-axis at 3, exactly, yeah, at 3. And it will cut the y-axis at 2. So it's going to be something like this, where the cover, let's call it the cover, I like this term, is z equal 6 minus 2x minus 3y. This is the cover. And the region R is a triangle where the line goes from 3 to 2. So this is the region R on which we need to integrate. And this line, which is important, we can get it from here by putting z equals 0. Very good, thank you. Yes, z equals 0. So you will get 2x plus 3y equal to 6. And we can find y from here. So y will be 6 over 6 minus 2x over 3 like this. So it's going to be 2 minus 2 over 3x. So once I've done all of this, this is like preparing everything. Now I can write that the volume will be the integral over R of What do I put here?
6 minus 2x
Yeah.
minus 3y.
The cover, yes, the cover. 6 minus 2x minus 3y dA. And now, over R, I can split this into the integral with respect to y, maybe, first. From y equal 0 to 2 minus 2 over 3x. And then the answer, I will integrate it with respect to x from 0 to 3. That's it. After that, I will leave you the rest to continue. That's it. I think if you understand what we did today, that's all you need for these integrations, areas, volumes, center of mass, etc. Every exam you will get, you will not get more difficult than these questions. So if you understood today's class, you know how to do these things, you will be fine. Okay then, girls. Thank you for your attention, and I will see you next time for some reviewing. Okay? All right. Thank you.